In this video, we want to look at linear regression in action. I'm going to show you a very easy and simple way using your calculator to field questions just like the one you see in front of you on the screen right now, number 20, which is about flight time and ticket price. So the question reads, flight time and ticket price. The following data represent non-stop flight time in minutes and one-way ticket price in dollars for flying from Chicago to various cities on Southwest Airlines. Now this is a data-driven problem, meaning that before you can even start to field any of the parts of the question, as you can see here, you got to get this data keyed into your calculator. And as I've mentioned elsewhere, whenever I do a data-driven problem, the first thing I always do, because I don't want to have any artifact data hanging around from some previous problem that I might have been working on, which is going to contaminate what I'm doing right now. So I would go to my calculator and I would use the stat menu here, number 4, the clear list function, and I want to wipe my lists, at least the ones that I'm going to be using for this particular problem. So I'll select that by hitting number 4, and I'll tell it the names of the lists. And so now those lists are ready to receive some data. And so to key it in, you'd go to the stat menu like this, and you would select number 1, the edit function, and you can just start keying it in. Now look again at the problem. We have the time of the flight given in minutes, that's the T list, and then we have the price of the flight given in dollars, that's the P list. So here's what I'm going to be doing. I'm going to use the list 1 in the calculator to hold the T data, and I'm going to use list 2 in the calculator to use the P data. P is in Paul. And so if you have a calculator handy, I would suggest you might want to consider joining me in keying this data in. It's just like this, and so on. And so again, here's the data from the problem. If you take your calculator, you can pause the video and then take the time to key this in and then resume the video, and we can pick it right up. So take a look at the table here, and you can see these data values, even though they're given in separate lists, they are effectively being treated as ordered pairs. So in other words, 110 and 129 are combined to make a single ordered pair, 110, 129, and so on. So in other words, when you're keying this data in, you need to make sure you key in both lists in exactly the same order. If you go top to bottom on T, then you go top to bottom on P, and so on. Here's my data keyed in, and as you can see, it matches the table exactly, which we want. We are ready now to start fielding the various parts of the question. So the first thing that we're asked here is in part A, it says use a graphing utility to draw a scatter diagram. So in other words, they want us to use our graphing calculator to come up with a scatter plot or a scatter diagram. So how do you go about that? Well, after your data is keyed in, you can quit this here, and you need to go to the second y equals submenu, the stat plots menu. And you may have some of these plots turned on. You really only need one. So if you have to turn them off, you can use function number 4 here, plots off, and that turns off all the plots. Now in my case they were already off, but I just wanted to show you that feature. So select one. Let's take plot number 1. First thing you need to do is turn it on, and then you need to select the correct type of plot. Now the one that's flashing is the one that we want, so you press enter to affirm that, and you can see now that the calculator is going to be looking in list 1 for the X values and list 2 for the Y values, and that's what we want. So in order to get that on the screen, I would quit this, and you can use zoom, and the function you're looking for is number 9 down here, zoom stat. And what that will do is it will give you a nice window size, which will give you a reasonable view of the plot, whatever it is that you're trying to make. In this case, a scatter plot. And so as you can see, there is our data set. And so again, the horizontal axis is the T axis, and the vertical axis is the P of T, the price of the flight as a function of the duration. So now we're ready to go back and see what else they're asking. It says in part B here, use a graphing utility to find the line of best fit that models the relation between flight time and airfare. Express the model using function notation. Okay. So in other words, they're asking for the regression line, and they want us to use flight time as the input variable and airfare as the output variable. So how would we go about that? Well, we go back to our calculator, and we need to go back to the stat menu. And you can use the arrow key to go over to the calc submenu. the function we're looking for is number 4, linreg, which is short for linear regression. That's the line of best fit. So to select it, you can press number 4. And my calculator has this sort of cut and paste interface here. You may not see this screen if you're running an older model. But anyway, again, we want to use list 1 for the input values, and we want to use list 2 for the output values. Now, I could talk about frequency list and store regression equation and so on, but since you may not have the same model that I have, and I want to show a method that will work for all of the various models, I'm not going to talk about those. I'm just going to cut to the chase. So we're ready to run the model, and the command is going to flash very briefly on the screen. You'll see it says linreg L1, L2. So in other words, the calculator is running the regression model on list 1 and list 2, just like this screen shows here. Press enter. Model runs, and there is your regression equation, your line of best fit. Now you probably want to jot this down. And one of the questions that typically comes up in connection with this is, well, how many decimal places do I need to write? And that's a good question. So for something like this, I would say, reasonable accuracy would be 3 or 4 places for both the slope and the y-intercept. So in other words, the slope is a here, and I would render that as 0.4755. Right, that 4 right there would be rounded up to a 5 because of the 8. Likewise, the b, the y-intercept, would be 64.0143 to 4 places. And so you can go ahead and jot that down. Now, as far as the rest of the parts, we want to use the full precision of the calculator. You have to know that for many regression models, if you retype what you see on the screen right here, you're propagating a round-off error. And for certain kinds of regression, like exponential or quadratic, those models are very sensitive to round-off error. And so you could be doing the whole process correctly, but if you're propagating a round-off error, you're probably going to get numbers out of the model which are not going to be accepted by MyLab. And that's another thing to note. When you're doing this type of a problem in MyLab, they will typically tell you how many places they want. And so as long as you follow those instructions faithfully, there should be no problems. So I want to take this regression line here and I want to save it for future use. And so the best way to do that is to go to the Y memory register here. And instead of retyping it, I'm going to fetch it from the memory. So I'll go to the VARs menu, and the function I want is number 5. It would be the statistics submenu. And then I'm going to use the arrow key to go over to the equation submenu. And you can see number 1 is highlighted there. That's the regeq, short for regression equation. So that is the name of the memory register that has been storing, or that is storing, the most recent regression calculation that the calculator's done. That's what we want. So all we really have to do is press enter, and then press enter again, and you can see that our regression model has been saved for us now in the Y1 memory register. And so we're pretty much ready to move on to the next parts. So in response to part B, they are asking you to write that model down using function notation. That means they want you to use P of t, price as a function of time. And so you would write that down, as we said, 4 places for the slope and 4 places for the y-intercept. Now part C is asking you to interpret the slope. And that is actually an intermediate algebra question. I don't know how long it's been since you've had intermediate algebra, but very briefly, what do you need to know in order to field that? Well, when you do regression, that is a very common question. What's the slope and what does it mean? And in order to field it, you have to know what the units of measure are that are attached to the slope. So you can choose y units divided by x units, in other words, output variable divided by input variable units, or you can go with y units divided by 1 x unit, in other words, a unit rate. Most people find that the unit rate is the easiest one to articulate. And so that would be the one that I would choose in this case. I think you'll find that it works rather well. So in response to the question, interpret the slope, here's our slope right here. We said it was 0.4755. And so if you were to render that as a ratio, which is a little bit more user-friendly, you could render that as 0.4755 divided by 1. And so the numerator in that case is your P, which means that's dollars, and your denominator is flight time in minutes. So the units of measure attached to this slope right here would be dollars per minute. And it's a positive slope, meaning that the y values are increasing as the x values increase. You can see that on the graph. And so a nice explanation of what that slope means in 25 words or less would be that on the average, for every 1 minute additional of flight time, the cost of the flight increases by about 47.5 cents. Again, for every 1 minute increase in the flight time, the price of the flight increases by about 47.5 cents. And that's a very good way to explain what that slope means. Now, for the other parts of the question, again, it's helpful to step back and look at kind of the big picture. What are they typically asking? So here's our list of questions again, and these are the questions that you'll typically encounter when you're fielding a linear regression situation. And we don't have an example of number 2 in this particular problem, although that's not an uncommon thing. And we can talk about that a bit later, but we do have examples of number 3 and number 4. And so one thing you should know when you're fielding regression questions, it's very common for number 1 and number 2 to be asked, just as you see right here. In other words, they're asked openly. But the last 3 parts, number 3, number 4, and number 5, those are generally not asked openly. In other words, what I'm saying is they are asked using the context of the problem. So for example, number 3, given x, which is an input value, find y, the corresponding output value, it's never asked that way. It's asked like you see right here. In part D, it says, predict the airfare for a flight from Chicago to Kansas City, Missouri, if the flight time is 90 minutes, round to the nearest dollar. So in other words, when you read that, they are counting on you to recognize, hey, wait a minute, 90 minutes, that's an input value. They must be asking me to find the corresponding output value, the airfare, for that input value using the regression model. And that's exactly what they're asking. And so you can do it by hand, but it's much easier to let the calculator do it for you. And here's how you do it. Now, if you recall, we had stashed the regression equation in the y1 memory register. And so if we look at the graph right now, you can see that the regression equation has been superposed over the graph of the scatter plot, which is what we want. We want all this on the screen right now. We want to refine the window size a little bit, though, because it turns out for the types of questions we're fielding now, part D and part E, if you can't see the answer on the screen of the calculator won't be able to find it. And so typically, this kind of a problem would require a little bit of fine-tuning of the window size in order to permit these types of questions to be answered. And so what would I do in this case? Well, I'm looking at the window size here, and the x min is the minimum x value that's displayed, and the x max is the maximum x value. So I'm going to change that to 0, and I'm going to take 306.5 and round it up to 350. The basic idea is I'd like to have a little bit of breathing room around my data set and my model so that I can field these types of questions. And as far as the x scale is concerned, if you recall, I mentioned in a different video, that is the distance between the hash marks on the x-axis. So you could leave it the way it is, but if you want a nicer looking graph, you need to choose a more appropriate value. And so in this case, I'd probably go with 100, something like that. And likewise for the y values, I'm going to change 80 to 0, and the y maximum, I'll just make it 300. Now, I don't have any hard and fast rule for picking these numbers. I mean, there's a certain amount of experience, obviously, but I'm just making my window bigger so that I can see everything more clearly. And then I'm going to choose, I'll go with 100 for the y scale as well. Now, these other values down here, the x resolution and the delta x and so on, don't mess with those. There's no reason for it, and you may cause your calculator to have problems in terms of display, and you may not be able to resolve it easily. So just leave those values untouched. If you look at the graph now, here's our graph, and you can see that we've opened up the window a little bit so we can see things better. We can see the y-intercept right here, which is very good if you were looking for that. And we'd like to now field the question that they asked. They said again, predict the airfare for a flight from Chicago to Kansas if the flight time is 90 minutes. And they want us to round the answer to the nearest dollar. So the slick way to do that would be as follows. You go second trace, and we're inputting a value. So select number 1, and then give it that flight time, 90 minutes. And you'll notice that right over here, the calculator spits out the corresponding cost according to the model. And so the cost we're getting here is $106.81 if you round it. They told us to round it to the nearest dollar, so that would be rounded to $107. And so that is the answer to part E or part D right there. It says round to the nearest dollar. It's $107. And so now we're ready to field part E. And it says predict the flight time from Chicago to Reno, Nevada, if the airfare is $180. Now, if you go back to our list of questions, that is an example of number 4. They have just given us an output value, the cost of the flight, and they're asking for the corresponding input value, the length of the flight in minutes, or the flight time. Now, you can do that by hand, but it's much easier to let the calculator do it for you. And the way we would do it is as follows. We're going to put in a horizontal line here at 180. That is the cost of that flight. And when you go back to the graph, you can see that what we're looking for is the intersection of those curves right there, or those lines rather. In particular, we want the x-coordinate of that intersection. Now, you could probably use the trace function, but as I mentioned previously, you know, the trace function, the accuracy of it is subject to the window size. And so the trace function is probably not a good choice here because we have quite a large window, and so it would be very easy to miss the value substantially using the trace function. A far better way would be like this. Go to second trace, and we want to use the intersect function. So in other words, we want the calculator to find the intersection of the line, or the two lines mathematically, and that's much nicer. So you hit number 5, and as you can see, it's asking you, well, what do you want to use for the first curve? Well, I want to use the regression equation. So press enter to affirm that choice. And then for the second curve, I want to use the red line, the horizontal line. So again, press enter. Now it's asking you to get it in the neighborhood of that intersection. So you could type in a value if you wanted, or you can just use the arrow key to go over somewhere around there. And then press enter again. And now the calculator is coughing up the answer that we were looking for. We wanted that x value that corresponded to a y value of 180, and we have it. The calculator is giving it as 243.93038, and so on. Now, that is a flight time in minutes, and they told us to round it to the nearest minute. So if you round it, it would be 244 minutes, and that is the answer to part E. Now, if you had retyped the regression model, in other words, if you just typed in 0.04755 and so on, there is a chance that this type of answer would not come out because you're going to have a round-off error to deal with. And so it's sort of like a ripple effect that you set up when you retype. It's far better to do as we did and to get the fully accurate regression model from the memory of the calculator. So we've answered all the parts. I'd like to recap the answer for you so that you can make some sense of this here. Again, let's look at our display. So we were talking about these 5 questions, and these are all fairly typical questions that you would be asked in conjunction with a linear regression model. What do you need to know? Well, as we said, for the slope, you need to know the units of measure. For the intercepts, if you're asked, you need to know what the 0 coordinate represents. So the x-intercept has a y-coordinate of 0, the y-intercept has an x-coordinate of 0, and you need to be able to articulate what the 0 means in the context of the model. If you can do that, it's very easy to explain what that is. We showed you how to do number 3 and 4 using the model, and regarding number 5, it's helpful to know that when you're looking at a point in relation to the regression model, the regression model represents the average value. And so if the point in question is above the line, that would suggest that the y value is above average. And likewise, if the point in question is below the line, that would suggest that the y value is below average. I just want to make sure to mention that. Now, as far as the answer to the question that we're after, here's the answer right here. So if you recall, part A was asking for a scatter diagram. We gave it to you on the screen. Part B was asking for the regression model expressed as a function of t. And so the answer that we gave was P of t equals 0.4755t plus 64.0143, so slope and y-intercept. Regarding part C, the slope is $0.4755 per minute, as we said. And the interpretation is that on the average, for every additional minute of flight time, the price of the flight increases by about 47.5 cents. In Part D, they gave you an input value and they were asking for the corresponding output value. So we showed you how to do that on the calculator. The corresponding output value in question was 107 when we rounded it per their instructions. And then finally for Part E, they gave us an output value, in other words a P value, the price of a flight, and they asked us to find the corresponding input value, the time of the flight, which we did, and the answer was 244. So I hope that will be helpful. If you have any questions, please drop me a line, but in general, your regression equations are all pretty much like this.